In this series, we're taking a look at the 4 free response questions from the 2024 AP Precalculus Exam. I'll leave a link in the description for the first video, which goes through problem number 1. This video is going to go through problem number 2, and this is still from the graphing calculator section where they've given us 30 minutes to do these first 2 problems. This problem covers concepts like logarithms, solving systems of equations, and average rate of change. So number 2 says, on the initial day of sales, t equals 0 for a new video game, there were 40,000 units of the game sold that day. 91 days later, t equals 91, there were 76,000 units of the game sold that day. The number of units of the video game sold on a given day can be modeled by the function g given by g of t equals a plus b times the natural log of t plus 1, where g of t is the number of units sold in thousands on day t since the initial day of sales. Now, in just a minute, I promise we'll get to actually solving this problem, but before we dive into actually calculating anything, let's first make sense of what's initially said in this problem. They start out by giving us some data, so we have t equals 0, that's our starting point, and we're starting with 40,000 units sold. And then t equals 91, there were 76,000 units sold. We could turn these into points. So t equals 0, and the output was 40. And I'm only going to write 40, even though it says 40,000, because then down here, it says g of t, in other words, this is the output, is the number of units sold in thousands. So 40,000 is just going to be represented as 40. And maybe that sounds kind of obvious, but it's important to note that kind of thing, because sometimes they'll trick you by having the units not match up. And then we can take the other point, 91 days later, we were at 76,000 units sold. And so they've basically given us x, y coordinates, except for in the terminology of this problem, we're using t and g of t. And then they tell us that the model we're going to use is this natural log function. And while it might not be immediately relevant in this problem, I think it's a good idea to try to visualize what's going on here. And you do have a graphing calculator, so you could even just plug a function like this right into like your y equals screen and just choose some value for a and b, because we don't know what those are yet. And then obviously you type x here instead of t. That's not really necessary though. I remember that a log function basically looks like this, and the a value in this function is just going to move it up, this t plus 1 is going to move it left 1, and then this b is going to vertically stretch or shrink the graph. So this thing has been moved left 1, it's been moved up or down by whatever a is, and then it might also be stretched or shrunk. But it's going to have this general shape. And remember, we're talking about the number of games sold. So I guess this makes sense because we're increasing sales rapidly at the beginning, and then as time goes on, sales are kind of leveling off. Alright, so let's solve the actual problem. Part A says use the given data to write 2 equations that can be used to find the values for constants a and b in the expressions for g of t. Notice we don't actually have to calculate anything here, we're just going to plug in the values that they gave us. And remember, those are the points 0, 40 and 91, 76. So if I start with the output g of t, that would be 40. Equals a plus b, because I don't know what those values are. I'm actually writing an equation where I can solve for those. And then I'm plugging in t, in this case that was 0. Then we'll use the next point, so 76 is the next output, equals a plus b, because again I still don't know what those are, times the natural log of, in this case, 91 plus 1. And so there's our 2 equations. That's actually the answer for this first part. We don't actually have to do anything with it. Part 2 does say find the values of a and b as decimal approximations. So now we actually have to solve this system. And I know at first glance it looks very complicated, but let's see what we can maybe simplify. In this first equation we have 40 equals, so there's nothing to do there. A plus b are variables, I don't know anything about those. But natural log of 0 plus 1 is something that I could potentially even type into my calculator. You might not really need to because 0 plus 1 is 1, and natural log of 1 is 0. If you remember, any kind of log of 1 is going to be 0. So that first equation really says 40 equals a plus b times 0. And b times 0 is 0. So right away, without doing much work, I can see a equals 40. Maybe we can do something similar to that in the second equation. So here we have natural log of 91 plus 1. That's not going to be so easy to calculate. But now I also know what a is, so I could plug that in. So taking the second equation down here, we've got 76 equals 40 plus b times the natural log of 92. And it might be tempting to grab your calculator and type in natural log of 92 and see what that equals. You can if you want, but I'd actually rather that we leave it written like this in the problem for now. We'll calculate everything at the end. But I'm just going to subtract 40, because that's easy to do. So we have 36 equals b times the natural log of 92. And now to solve for b, I just have to divide both sides by the natural log of 92. And honestly, I don't know that it's much easier or harder to write natural log of 92 than it is to write whatever the decimal approximation is of it. So this all cancels out over here, and then we have b equals whatever this is, and now we'll use our calculator. We should get about 7.96, and so there's our answer for part 2. Part B says, use the given data to find the average rate of change of the number of units of the video game sold in thousands per day from t equals 0 to t equals 91 days. Express your answer as a decimal approximation. Show the computations that led to your answer. Alright, so this is very wordy, but really it's just saying find the average rate of change between these 2 days. And remember, we have these points 0, 40 and 91, 76. So if you graph these 2 points, you can see we have 0, 40 on the y-axis, and 91, 76 is way off to the right and above that. And we solved for a and b in the last problem, so that means we actually have the full equation that we're using to model these 2 points. We could actually graph this log equation and see that it goes through those 2 points basically. But the average rate of change is basically drawing like a straight line segment between those 2 points. I don't care about the curvature of this log graph, I just want to see straight from point A to point B. And another way to think of average rate of change is just the slope. How much did these 2 points change on average from point A to point B? So we'll just take the rise and divide by the run. Well, to figure out the rise, it's just the y value is going from 40 to 76, so it's increasing by 36. And the run is going from an x value of 0 to 91. And that'll give you about 0.396. Number 2 says use the average rate of change found in part 1 to estimate the number of units of the video game sold in thousands on day t equals 50. Show the work that leads to your answer. So we are just estimating. We're not using the model to figure out how many games were actually sold on day 50. We just want to estimate using the average rate of change. And this average rate of change value that we found is in decimal form, but if you wanted, you could put it like over 1. And that'll just help us to rethink of this, again, as rise over run. So every time we go over 1 day, that's the run, we would go up 0.396. Also, remember that our y value, the rise, or the outputs here, these are measured in thousands. So 0.396 actually means 396 games. Well, we want to figure out how many games were sold on day 50. So we could take this 0.396 over 1 and multiply it by 50 over 50. This is okay to do because 50 over 50 is just 1, so it's not going to change the value. But it will give us some other value on top, and the denominator will be 50, which is what we want. And I'm getting 19.8 for the numerator. So that means after 50 days have gone by, 19.8 thousand games were sold. Part 3 says, let A sub t represent the estimate of the number of units of the video game sold in thousands using the average rate of change found in part 1. For A sub 50, found in part 2, it can be shown that A sub 50 is less than G sub 50. Explain why, in general, A sub t is less than G of t for all t, where 0 is less than t is less than 91. So first, let's just agree that yes, that is a mouthful to read, and even if you're reading it in your head, it's a lot. So let's pick out what's really important here. They're introducing A sub t, and they're saying let it represent the estimate of the number of units of the video game sold in thousand using the average rate of change. Okay, so A sub t is referring to average rate of change. This is just the math symbol that they're going to use for that now. And it's what we did in part 1, so we're good. For A sub 50 found in part 2, so that's using the average rate of change to find the output for the 50th day. That's what we just did. It can be shown that A sub 50 is less than G of 50. Well, what the heck is G of 50? If you go back to the beginning of this problem, the function g is just the natural log function that we came up with back in part A. So they're saying A sub 50 is less than g of 50. In other words, if you find the value using the average rate of change, you're going to get a smaller outcome than if you use the actual model. The model is giving us a higher value. You don't actually need to figure out what that value is. You can take their word for it, but if you want, you could plug 50 into our function and see what you get out. So the actual question is saying explain why in general the average rate of change value is going to be less than the model value for all t between 0 and 91. Well, the days between 0 and 91 are all that we have to work with. That's all we've been told about. We don't care about any of the values before or after that, so that makes sense. And if you're not sure where to go with something, and especially if you have a graphing calculator available, try looking back at the graphs. We've seen what this log graph looks like, and we know that the average rate of change is just going to be a line segment between these 2 points, and you can see how the log graph is concave down. Because the graph is curved this way, it's always going to be up above the line segment. In other words, the model is always greater than the average rate of change, or flip that around, the average rate of change is always less than the model, at least between these two endpoints, 0 and 91. And the last part of this problem, part C, says the makers of the video game reported the daily sales of the video game decreased each day after t equals 91. Explain why the error in the model G increases after t equals 91. So if we continue to use our natural log function for the model G, we know that this function is always increasing. But now they're saying that the video game sales actually decreased each day after t equals 91. So if our model is always increasing, but the actual data shows decreasing sales, the gap between those two things is going to increase. It's kind of like we're expecting the sales to keep getting bigger and bigger, even though they're actually going lower and lower. So the difference between our expectation and reality is growing. It's getting bigger and bigger. So the error is increasing. And log graphs, if they're increasing, they will always be increasing. They don't ever turn around. They don't have a vertex. They don't start decreasing. So this error value will continue to increase forever. All right, and that's it for the first part of the free response questions. Again, on the test, you'll have 30 minutes to complete this section. And don't forget to check out the other videos for problems 3 and 4.